So today we're going to be looking at completing the square, which is the way to get from standard form to vertex form. I'm also going to be showing you a bit of a shortcut, and then we will work on some application problems in vertex form. So completing the square takes an equation from standard form to vertex form. This is necessary to find the vertex of the parabola. This method will work every single time, so all you have to do is remember the steps. Okay, so step one, we're going to group the first two terms. So we can just bracket these terms. You're just pulling out the first two terms. And then we're going to factor out the coefficient of a, so the term in front of the x squared. In this case, it's just 1, so our work is easy. It's done. And so we're just going to repeat this line. Next step is we're going to add and subtract the square of half of b to make it a perfect square trinomial. So we're going to take our b value, which is 8, and then we're going to take half of 8, which is 4, and square it, which is 16. Now I'm going to add 16 and subtract 16 because really that's a net of 0. We don't really want to change it. We're just kind of rearranging it so we can get our perfect square trinomial. So basically what we're doing is like reverse man. We're trying to engineer it so that we can create a perfect square trinomial. Then we're going to move the subtracted term outside the brackets. In this case, because our a value is 1, this is pretty easy. We just pull it out because it's really multiplied by 1. It's going to get more complicated if your a value is not 1, but we'll do those examples as well. And then we're going to factor the perfect square trinomial. So notice this is a perfect square trinomial. And if you're not sure, say you forget the pattern, you can always do man here, right? So you can always think, okay, two numbers that multiply to 16 and add to 8, that's 4 and 4. And so you know it's going to be x plus 4, x plus 4. But hopefully you've seen this pattern before in our factoring unit and you remember it, so you know this is a perfect square trinomial. And then we're just going to clean it up, simplify it, and this is now in vertex form. Okay, so the last part here is just interpreting the vertex. So remember, it's in vertex form, so your vertex is -4 and -11. Remember, x always lies, it never tells the truth, so the sign is going to always flip for the x value, which is the axis of symmetry. So for this next one, I want you to try it with me. Feel free to pause the video if you need. So for the first two terms, we're just grouping them together. And then same idea here, we have an a value of 1. And so we don't need to factor anything. It's already done for us. Now we're going to take the b term, which is -4, take half of that. So it's going to be -4. I'll just do side work here. Divided by 2 and square it. So that becomes -2 squared, which is 4. And so we're just going to copy down those two terms. Plus 4 minus 4 minus 1. This is your perfect square trinomial. So it becomes, okay, I don't want to skip a step. So plus 4, we're just going to group those together, take the -4 out of the brackets, and now we can factor this perfect square trinomial to x minus 2 squared minus 4 minus 1. Last step is to put it all together, just clean it up. So we get -5. Your vertex here should be 2, -5. Okay, now let's do an example where your a value is not 1. So we're going to have to factor out that a value. So same way, we start off by grouping the first two terms. Now the second step is to factor out the a value, so the coefficient in front of the x squared. And so we're going to take out the 2 here, and this becomes 2 x squared plus 6x plus 11. And now we're going to repeat the steps we did before. So we're going to take that b value and take half of it and then square it so we can get a perfect square trinomial. And then we're going to move the outside term outside of the bracket, but because we have an a value here, we can't forget to multiply it by 2. So it becomes this. And now we can factor our perfect square trinomial and simplify. Now here our vertex is going to be -3, -7. And remember that because you have an a value of 2, that just means there's also a vertical stretch of 2. Okay, let's try the next one together. So we're going to just isolate those or bracket off those first 2 terms. And then we're going to factor out the a value. So you're pulling out a -3, and this becomes -8. And now we're going to take half of -8, which is -4, and square it, which becomes 16. So we're going to do plus 16 minus 16 minus 50. Okay, I'm going to have to write smaller here. X squared minus 8x plus 16. That's your perfect square trinomial. Then we get -16. Remember to multiply it by the -3, because really it's in the bracket, so that means the distributive property would have taken effect if we didn't pull it out. And now we have a perfect square trinomial, which, remember, if you forget, you can always use man here, but we know the pattern. So this is going to be x minus 4 squared plus 48 minus 50. So when we simplify it, we get x minus 4 squared minus 2. Your vertex is going to be 4, -2. And remember, it's inverted, so it's flipped on the x-axis because our a value is negative. And there's a vertical stretch by a factor of 3. Okay, so here I'm going to show you a shortcut. I'm going to show you the first example from each page, and I encourage you to try the other ones on your own. Okay, so here's a shortcut. There's an equation for the axis of symmetry, which is the x value of the vertex. That's -b over 2a. So we're just going to take our, remember, a value here is 1, b is 8, and c is 5. So you're just going to plug this in, so we get -8 over 2 times 1, which is -4. So that's going to be our axis of symmetry, which is the x value for the vertex. Now to get the vertex, like the y value, we're just plugging it in. So you're just putting in -4 into your x value. So -4 squared plus 8 times -4 plus 5. This becomes 16 minus 32 plus 5. And that is -11. And if you look back, your vertex is indeed -4, -11. So you found your values. Putting it into vertex form is just kind of working backwards. So you know your a value is 1. Okay, in this case, we don't have an a value. We know the axis of symmetry is -4, which means we're going to have to flip the sign because remember, x lies. So this is going to be x plus 4 squared minus 11. And there you go. You got it in vertex form. Okay, so this is the second page, first example. We're going to try the exact same thing. To find your axis of symmetry, you're just using -b over 2a. So that's going to be -12 over 2 times 2. So -12 over 4, which is -3. Now we're just going to take our -3, put it back into our x as our x value into the equation. Times 9 minus 36 plus 11. And that is -7. And so we have our vertex, which is -3, -7. And now you can put it back into vertex form. You know your a value is going to be the same because think back to our process. We had to pull out that a value. It hasn't changed. So it becomes x. Remember the sign flips. It's going to be x plus 3 squared minus 7. And you're all done. Obviously, this way is easier, but it's good to know both. Okay, as our first example, a diver dives into a swimming pool, her height h of t in meters above the water in terms of her horizontal distance t in meters from the end of the board is given by the following equation. What is the diver's maximum height? So if it's asking for maximum height, we know we have to find the vertex because that will be the maximum height. We know it's maximum because look at our a value. It's negative. And so you know that it's facing down. So first thing we want to do is put this into vertex form so we can complete the square. I've gone ahead and grouped my first two terms. Now I know the value of a is -1. I still need to factor it out. So it's going to become t squared minus 2t plus 3. Next step, I would take half of my b value, which is -2. So take half of it becomes -1, square it becomes +1. So we're going to add 1, subtract 1. You can tell this is your perfect square trinomial. Then we have -1 plus, and then times -1 because that's our a value. So don't forget about that. And then we get t squared minus 1 squared plus 1 plus 3. Oops. Okay, so just to clean this up, this becomes plus 4. And it's asking, so we have a completed vertex form, and so we know the vertex is 1, 4. So it wants to know what the max height is, and so our max height is going to be 4 meters, right? Because if you think about the vertex, if we just want to draw this as a graph, this is the horizontal distance, and our vertex is going to be up here, and it's going to look something like this, the parabola. And so this is what they're asking for. The max height is going to be 4 meters. Now, I didn't draw this so well, but if you want to figure out her initial height on where she started, look at the y-intercept. So remember, we talked about this in class. Her starting height would actually be 3 meters. Okay, moving on to example 2. The path of a firework can be modeled by the following equation. After how many seconds does the firework explode? How high above the ground is it at that point? So clearly we're looking for the vertex here. Just to mix it up, I'm going to use the shortcut. So you're familiar with both ways. Unless it specifies to complete the square, you're more than welcome to use the shortcut, but it may specify to complete the square, so definitely know that. So our b value is 30, so we get -30 over 2 times -5. So that is -30 over -10, which is +3. And now I'm going to put 3 into my equation. So we get 3 squared plus 30 times 3 plus 35. Which this becomes 80. And so our vertex is going to be 380. Okay, this answers the question right away, but I do want to put it back into vertex form just so we're familiar on how to do that. So our a value is still going to be -5. And we know that x lies, so it's going to be t minus 3 squared plus 80. Okay, so now we can answer the question, how high above the ground is it at that point? So we know that it's going to explode at 3 seconds, and it's going to be 80 meters off the ground at that point. So it'll look something like this, and just for bonus here, the initial height is going to be 35 meters starting, because that would be at t equals 0. So initially our y-intercept is 35 meters.